Greetings, Science of Acoustics students. It is March 18th, 2020, and this is Tim McCaskey. I'm one of the instructors for the course. We've been disrupted a little bit by COVID-19 here, and so what I'd like to do is demonstrate in such a way that you can take some data from it, the resonance tube experiment. So what we have here is a tube of water, and the level of the water is adjustable, so we can control how long the pipe is, and measurements in centimeters are listed here. We are currently in a room, let's take a look here, where this is the temperature. This is a Celsius thermometer. Should be careful not to touch the end, actually. This is in Celsius. And see the numbers on that, I hope. This is around what it normally is. It feels a little cooler in here than normal. Anyway, the way this works is I use this metal cup as a reservoir, and this is adjustable. So if I drop the cup, then the level in this tube drops to match. And what I'm going to do is I'm going to use this tuning fork. So I have a 1000 hertz tuning fork, and I'm going to strike it on something, and then I hold it above like this. And our goal will be to find the points at which this is the loudest. So I'll make the water level go up and down a couple of times, and you should be able to judge from this video where the sound is the loudest. When it's the loudest, that means we have the best, most resonant standing wave in there. And for our first example, if you treat the closed end of this tube as a node and this as an antinode, we can get an idea for what 1/4 of a wavelength is. And we'll get loud spots again when we can fit in 3/4 of a full wavelength and 5/4 of a full wavelength. I'll make those separate videos. But for now, I just know from experience most groups for this measure something between 6 and 10 centimeters to be the first spot where it's the loudest. I think the thing to do is just to do it. I'm going to strike the tuning fork first, hold it above the open end, and then lower the water level. I'll try to do it slowly. Hopefully you can see from this video where the loudest, where the loudest sound happens. So let's do that. First, I'm going to loosen this to prepare to lower it, and then let's go. Okay, so the loud sound clearly went and passed. Let me do it again, going the other direction. Should be about the same place. Okay, I'll check the sound on that. I think it worked out fairly well. What this gives us is a baseline, so it's not going to be perfect, but around triple whatever that distance is and 5 times whatever that distance is, again approximately, we're going to get that loud sound again, and those will give us clues as to what the wavelength of this sound is, and therefore the speed, because again, we're using a 1000 hertz tuning fork. Right, so I hope you heard that. The next 2 videos will be the other loud sounds with slightly longer tube lengths, and I will link to those in the video description of this. All right, thank you.